In a cross product, two vectors multiplied together will produce a new vector. A good example of a cross product is torque, which is the product of R cross F. The cross product is similar to the dot product. However, there are three important differences to note. 1. The cross product of two parallel vectors will always be 0, and two perpendicular vectors will be equal to the multiplication of the two vectors' magnitude. This is because the sine of 90 is 1 and the sine of 0 is 0. 2. The multiplication of two vectors in a cross product produces a third vector that is at right angles to the other two vectors. How are we to represent the direction of this third dimension on a two-dimensional piece of paper or screen? The convention is to use a dot to represent a vector that is emerging out of the page towards the reader. A trick to enable visualizing this concept is to imagine that the dot is the tip of an arrow that has pierced the plane and is traveling out of the page at right angles to it. An X or cross is used to represent a vector that is receding from the observer and is piercing the plane by traveling into the page. The method for determining the direction of this vector is to use a technique called the right-hand rule. The third way in which cross products are different from dot products is that cross products are not commutative. Multiplying will actually produce the same magnitude, but the direction of the new vector will be different as determined by the right-hand rule.